In 5.4, we're going to talk about some more ideas about probability and how some people misunderstand what it is. So the law of large numbers just talks about if you repeat something over and over again, hopefully the empirical probability would come close to the theoretical probability. Okay, so the table to the right, I show the results of flipping a coin 10 times. Okay, so if I start calculating the empirical probabilities, you see the empirical probability if I just flip it once would be 1 or 100% of the times I got ahead. And we could go through and continue to do that. You notice it's still 100% even after 3 flips. And when I get to the 4th flip, because I finally flipped a tail, I'm now at 75%. Okay, so even after 10 flips, I have 1, 2, 3, 4, 5, 6, 7 heads. So I'm still at 70% chance of getting ahead. Okay, but again, these are all empirical probability. So remember, empirical probability is if you simulate the event versus theoretical probability, what you should get mathematically. Okay, so the law of large numbers says that if you have an experiment with a random outcome and you do it many times, that the empirical probability will get close to the true probability. Okay, you don't always have a theoretical probability, because sometimes you mathematically cannot figure out what the probability would be. So the empirical probability is what you get if you repeat it many times, and as you continue to do it many times, it should get close to what the true probability it is. Okay, and the larger the number of repetitions, the closer together these probabilities are likely to be. Okay, so here's that wink, blink, stare game that we played at the beginning. And if you look, I'm talking about in the long run. So how much is in the long run? So here's the beginning of the table, and this is when my students played it, then I gathered the data and we put it onto the table, and so I end up with 450 different times we played this. Okay, so then I made a graph, and if you realize the theoretical probability of getting a wink was 50%, and that was discussed in the last section. If you notice here, even after 450 times, well, it looks like I might be approaching the 0.5, but I'm not really there yet. Okay, so again, in the long run means after many trials. So even in this case, 450 doesn't actually get me to the theoretical probability, but it is getting closer. Okay, so if I flip a coin 1,000,000 times, it is likely to land on heads 50% of the time. It probably may not be exactly 50%, but it should be close to that 50%. Okay, or if I randomly survey 50,000 Americans and ask them if they know the capital of Ohio, right, the proportion I get just based on those 50,000 Americans should be close to the proportion of all Americans who know. We're talking about surveying in Chapter 7, so this is assuming that you did proper surveying methods, which we're talking about that in Chapter 7. So if you do proper surveying methods, whatever you get out of your survey should be close to what the proportion of everyone that's in your population. Okay, so in this last example is one where we can't actually figure out the theoretical probability. All I can have is an empirical probability. Okay, some things to watch out for. If the probability of something occurring is small, you have to use a lot more trials than if it's closer to 0.5. Same idea if it's very large probability, 0.95 instead of 0.05. Again, that means you have to use a lot more trials to get the theoretical probability and the empirical probability close to each other. Okay? And the other thing about the law of large numbers, it's in the long run, not in the short run. So if you just flip a coin 5 times and you get 5 heads, it doesn't mean that all of a sudden you need to get 5 tails just to compensate, okay? Because it's over the long run. Okay, it also doesn't tell you that streaks can occur. So just because you have 5 heads in a row, that's okay. It's not violating the law of large numbers, because only tossing it 5 times is in the short run, not in the long run. Okay, same thing rolling a dice. If you see 20 rolls and you never have a 2, that doesn't mean you're going to get a 2 on the next toss. The next toss, you're still equally likely to get any of the 6 sides of your dice. Hopefully you remember what the word fair, when I talk about a fair dice or fair coin, that means each side's equally likely to occur. Okay, so here's that same wink, blink, stare data file that I have. And if you notice, through here I actually ended up with 8 times they got wink in a row. Okay, does that mean they're going to end up with 8 string of no winks? No, because again, if you're talking about just 8 trials, that's all short term, and we're looking at long term, what's happening. in chapter 5 activity, you're going to investigate some of these ideas. Okay, the first one is the fact if you do get a long string, okay, does that really affect the empirical probability at the end? Okay, and the other one is the fact that you have to do many trials in order to get close to the theoretical probability. And a couple of those, the probability of an event occurring is very small, so that's why you have to do many, many trials. And then also out in sports, when they talk about certain players due for a hit in baseball, okay, you're going to simulate a batter at bat for a whole season and see how many streaks occur just in nature, just naturally when he's at bat. Okay, so that's the activities that you're going to do in chapter 5, and hopefully you see those 3 themes when you go through and do the activity. So enjoy your chapter 5 activity, and see you later.